We've all seen how powerful these general-purpose AI models can be, right? But what if you could take that raw intelligence and, mold it into a specialized expert that knows your world inside and out? Well, today we're going to dive into exactly how that's done. It's a process called fine-tuning. So you've probably been there. You grab a powerful, off-the-shelf large language model, you try to use it for a specific job, and it kind of falls flat. It doesn't get your industry's jargon, it doesn't understand your company's unique style, and it for sure doesn't have the specific knowledge you need it to be actually helpful. It's a super common frustration, and really, it highlights the core problem with these one-size-fits-all models. Okay, so how do we fix this? Here's the most important thing to get your head around. Fine-tuning is not about building a new AI from scratch. I mean, that huge, incredibly expensive work, it's already been done for you. The best way to think about it is like you're a sound engineer. You're not asked to build a whole recording studio from the ground up. Nope. You just walk up to the mixing board and start adjusting the dials and sliders to get the perfect sound for your specific song.
Right, so before we jump into the solution, let's just spend another minute on the problem itself. Why is it that these incredibly smart, one-size-fits-all models sometimes let us down?
It's really as simple as this. These models are trained on, well, basically the entire internet. And because of that, they're generalists. They're jacks of all trades. They can write you a poem, sure. They can summarize an article. They can even write a little bit of code. But when you need deep expertise in a really narrow field, like medicine or law, or even just your own company's internal documents, that broad knowledge actually becomes a weakness. It just doesn't have the specific nuance you need.
So that's the challenge, right? How do you take that jack of all trades and turn it into a genuine, world-class specialist? Well, this is exactly where fine-tuning comes into play. Okay, so what is it really? The most important thing to remember is that fine-tuning is a secondary training process. You take a model that already knows how to understand language and you continue its education. But this time it's with a very specific curriculum. It's your data. And this process adapts not only what the model knows, but also how it behaves. And that's absolutely crucial.
And this example, oh man, this just shows the difference perfectly. Take a look. On the left, a user puts in some pretty common skin symptoms. The base model, the generalist, gives a response that's, well, it's basically useless. Probably acne. Thanks. But look to the right. The model that was fine-tuned on dermatology data gives a precise, expert-level diagnosis. I mean, that is the difference between a random person's guess and a professional consultation. It's night and day.
And check this out, because this is a really powerful, kind of counterintuitive idea. It's not just about getting better answers. It's also about being more efficient. You can often take a smaller, cheaper model, give it the specialized training, and it will actually outperform a massive, way more expensive model on your specific task. That is a huge, huge advantage. Now, of course, fine-tuning isn't the only game in town. It's not your only option for customizing an LLM. So let's take a quick look at how it compares to a couple of other popular methods so you can figure out which tool is the right one for your job. First up, you've got prompt engineering. This is basically where you try to stuff all the instructions and context into the prompt itself. And you know what? It's great for quick tests, for building prototypes. But here's the catch. The model doesn't actually learn anything new. It can forget the context you just gave it, and it's way more likely to just make stuff up. Fine-tuning, on the other hand, that's what you use for production. The model truly learns from your data, and that means you get higher quality, more consistent results, and yeah, usually lower costs over time. Okay, next up is a technique called Retrieval Augmented Generation, or just RAG. The easiest way to think about RAG is that you're giving the AI an open book test. You literally connect the model to a live database of your information. So when you ask a question, it first goes and retrieves the relevant facts from that database, and then it generates an answer. This is amazing for tasks that need up-to-the-minute factual information. Fine-tuning is different. It's less about looking up new facts and more about changing the model's core behavior, its style, its tone, its skills. So here's a simple rule of thumb. Use RAG to give your AI new knowledge, but use fine-tuning to teach it a new skill.
Now you might be sitting there thinking, this all sounds incredibly expensive and super complicated. And historically, you would have been totally right. But a couple of breakthrough techniques have completely changed the game, making this stuff accessible to pretty much everyone. Let's see how. See, the original way of doing this, called full fine-tuning, meant you had to update every single one of the model's billions, with a B, of parameters. And this required a just enormous amount of computing power, time, and money. It put it way out of reach for almost everybody.
But then came this breakthrough called low-rank adaptation, or LoRA. The absolute genius of LoRA is just how surgically efficient it is. So here's how it works. First, you freeze the entire original model. You don't touch any of those billions of parameters. Then, you inject these tiny new trainable layers into the model. And finally, you train only these new small parts. So instead of retraining the whole thing, you're just tweaking a tiny fraction of it, which makes the whole process dramatically faster and cheaper. It's a game changer.
And believe it or not, it gets even more efficient. There's something called QLoRA, or quantized LoRA, which takes this idea one step further. It uses a technique called quantization, which is really just a fancy word for compressing the model itself. The best analogy I've heard is it's like turning a massive high-resolution image file into a much smaller JPEG. It can reduce the memory you need by up to 4 times. And here's why that matters. This makes it possible to fine-tune huge models on a single, affordable GPU. This is what's democratizing the technology, taking it from giant corporations and putting it in the hands of individual developers.
So, after all this technical talk, what's the actual payoff? Why should you, personally, care about fine-tuning? Well, it really all boils down to these 4 pillars you see here. First up is performance. You just get higher accuracy and more consistent results. Simple as that. Second is cost. Those smaller specialized models are almost always cheaper to run than a giant general-purpose one. Third is reliability. You own the model, so you control its speed, its safety, its uptime. And finally, and this one is a big one, privacy. You can run these models on your own servers, which means your sensitive data never ever has to leave your control. So there you have it. We've gone from a generic tool to a specialized genius, all through a process that is more accessible than it has ever been before. So, I guess the only real question left is, now that you have this power to create an expert AI for pretty much any domain, what are you going to build? What problem will you solve first?